So this is the test review for Chapter 9 of AICE 2, and we're going to start with this question here. The curve has equation y equals x times the square root of x cubed plus 1 between 0 and 2. Now this would be something that would be really difficult to integrate at this point, so we're going to do this by the Trapezium Rule. Now, one thing you might notice that was slightly different from this and the questions in class is they've already created a table for you. Like, they've already figured out what the height of the trapezoids is, or the width if you prefer. And they've actually given you some of the values as well. So part of the reason is it can take a long time to do this part. So in a short test, they'll often just ask you to fill in specific values. So you would plug 1 into this formula here and then find out what that gives you. We can probably do this one. 1 cubed is 1, plus 1 is 2. So square root of 2 times by 1. So you could put square root of 2, but the question says give the value to 3 decimal places. And then you do the same for 1.5 as well. Now, we actually have the answers at the bottom here, so we're just going to look to see. It does say that you should also allow the square root of 2, but if it says to go to 3 decimal places, I would go to 3 decimal places, and then 3.137 as well. So to get the points for this one, you literally just need to substitute in. That would be your first point, and then substitute in, for your second value. There we go. And then it says, using the trapezium rule with all the values from the table, find an approximation for this integral between 0 and 2. So notice 0 and 2 is the whole table. That's important. And this was the values that we were actually calculating. And once again, give your answer to 3 significant figures. So you should be able to find the formula from the formula sheet. So it's 1/2 the height, and then it will either say y0 plus yn, as in the first plus the last terms, or it'll do the first term plus all the middle terms, which I'm just going to leave like that because I can't write quite so well on here, plus the last term. And for 4 points, this is actually just a big substitution question. It's knowing what numbers we're actually plugging in here. So the height for this is actually what's the width for the x values, because our trapezoids are twisted around. So you'd start off with 1/2 times by 1/2, which is obviously a quarter. You then fill in, and I normally just actually bring these two terms together. So I would do 0 plus 6. And notice I am substituting rather than evaluating at this point. Like, obviously I know 0 plus 6 is 6, but I just want to show the examiner I know exactly what I'm doing here. Now, to make it easier, I'm just going to say it's these values here, all added together. So these are the middle values. So the first and the last term plus 2 times each of the ones in the middle. And then from here, as long as we do this in stages, we should be good. Like, I would work out this is 1/4. I know 0 plus 6 is kind of trivial for this question, but I would work out that as well. Plus 2 times, and then I would work out what all these numbers added together is, and then I could come up with my final answer. But a lot of this is just using calculators. One thing to notice then is, if you're not sure how to fill in this table, guess 2 numbers. Make sure they're kind of between these 2 numbers if possible. But then at least you can go on and answer the second question, even if you can't answer the first question. And correct answer was supposed to be 4.04, and you can see actually on the notes here they did the same thing. You got 1 point for actually getting the first part of the formula, and then you got 1 point for substituting into the second formula. Here's your method mark here, and then A for the final answer, which was that 4.04. And it does say must be the 3 significant figures. So we talked about this on one of the previous homeworks, on the previous test, chapter 8, where it said round your answer to a specific degree, and some of you just ignored that part of the question. All right, let's look at the AICE part of the question at the end for 3 points. Use your answer to find an approximation for the area of R, giving your answer to 3 significant figures. So what we notice here is they've drawn the curve for us. I'm going to quickly get rid of all that little writing that we had, and then we'll look to see what we actually did. So when we did the area, what we actually found is, that integral, what we actually found is we found the area under the curve. So there was our curve, and then we found out this part here. So actually, if I want to find the area of R, what I actually need to do is, it's a composite shape. If I find the area of the whole triangle, and then subtract this piece C, then that will actually give me what R is. So it's the area of the triangle minus, I'm going to have to go back to my pen here, minus C, and that will actually tell me what the area of R is. Now from here we can actually work out the area of the triangle. We know this was between 0 and 2. We know at 2 the value is 6, so we know that the height is 6. So 2 times 6 is 12. Do a half of that because it's a triangle, that would give you 6. And then C, we actually worked out before, it was 4.04. And therefore we can say that the piece R would be 1.96. And let's just take a quick look to see if we can find that. There we go. And notice that they're asking for method marks here, so make sure you explain exactly what you're actually calculating here, even the area of triangle. Just be very thorough in what you're actually doing, just so if you do make that careless mistake, the examiner can try and give you credit for that question.